Now, the next section that I want us to look at in terms of the diode application, it is your diode limiter circuit. The diode limiter circuit. Now, with the diode limiter circuit, you will have your circuit connection that will consist of an AC source. Then you will have your resistor or your limiter resistor. Then you will have the diode. Is it either a germanium or a silicon diode? Then you will have another resistor there connected in series with that one there, which means there is positive, there is negative, positive, negative. Then there you have got the positive and the negative. Let's say that one, it's 10K, then that one, 10 kilo ohm resistor, and that one is 100 kilo ohm resistor. 10 kilo ohm resistor, 100 kilo ohm resistor. Then if this is a germanium, if that is a germanium, then we know that with germanium, during current flow, which means this must be forward bias. If that is, let's say for an example, let's just change this, that is 5 volts peak during forward bias, which means now you're looking at this on a positive cycle. Now, germanium during forward bias. Now, if this is established during forward bias, which means now the current will be able to flow. If the current is flowing, what is the voltage that will be measured there? If the current is flowing, what will be the voltage which is measured there? You will see that your V out during your positive cycle, it is going to be 0.3 volts. Your V out during your positive cycle, it is going to be 0.3 volts. So which means when I measure according to this, remember you've got an input. Which means now your input moves within this magnitude there. Which means there you've got 5 volts positive. There you've got minus 5 volts. 5 volts positive minus 5 volts. Now, if I were to look at this at the output, then it says during the positive cycle, which means your current is moving in that direction there. During the positive cycle, it's moving in that direction there. Now, because the current is moving in that direction there, which means I've got a voltage drop here and also I've got a voltage drop there, but I am measuring the voltage across that component there. If I am measuring the voltage across this component here, because this is your main component. If I'm measuring the voltage across that component here, which means I will start, or it will start oscillating from 0, then up until this gets to be switched on. And you will see that it will only get to be switched on at what? At 0.3 volts. Then you will allow the current to flow. So which means you will keep on increasing this voltage, but that voltage there will never increase, which means it will stay the same. You can increase this voltage as much as you want up until the maximum voltage, but that one will remain as 0.3 volts, which means what I'm going to see here, there, I will only see 0.3 volts, which means this up until 0.3 volts. Once it gets to 0.3 volts, Once it gets to 0.3 volts, the voltage that this input increases to, it doesn't affect that component there. So which means you will remain at 0.3 volts. You will remain at 0.3 volts up until this cycle comes back to 0. Then you will see that it's going to be like this. Then from there, when you swap, or when this signal interchanges, which means now here you no longer have positive, you have got negative, there you no longer have negative, you have positive, which means now your current is flowing in that direction. If your current is flowing in this direction, which means it's going to force this component to move from, forward bias into reverse bias. If this is at reverse bias, it simply means that now it is acting as an open circuit. If it is acting as an open circuit, which means now you only have that component there. Which means the voltage that I measure across this component here, it is going to be the voltage that will be established by, then we look at the nature of the circuit. This component and that component, when this component doesn't exist anymore, these two, they are series to each other. Those two components, they are series to each other. Now, if those two components, they are series to each other, what does it mean? If those two components, they are series to each other, what does it mean? It simply means that now I am looking at this in this manner. Now I'm looking at this in this manner, which means now this cycle can go into its minimum peak. When it goes to its minimum peak, it simply means that when I look at this here, my V out during the negative cycle, because this is no longer there, it will be given by this component and that component, which are series to each other. If these two are series to each other, it simply means that I will have 100K divided by 100K plus 10K multiplied by, what is the maximum amplitude here? The maximum amplitude there is 5 volts, which means minus 5 volts. Then I get the magnitude there. If I want to define this circuit, you will see that it doesn't show you the whole of the circuit on the input side positively, only a certain portion. So which means it cuts off a certain portion, then it allows another portion to go through. Then now you have clipped off the positive cycle and you allow the negative cycle to go through. This is a positive clipper circuit or positive limiter circuit. You clip off or you limit the positive cycle, then you allow the negative cycle to go through. But for you to get the magnitude of the going through cycle, then you have to go and use a voltage divider rule equation. You use a voltage divider rule equation. But now, if we look at the same circuit, but now when we are looking at this circuit, we are looking at this circuit in this manner. Then we're going to say, now this component this component, it is now connected in this manner. This component, it is now connected in this manner. Positive there, negative there. Five volts, positive there, negative there. Then I say that is a silicon device. That is a silicon device. Now, with this circuit, it's different from the previous circuit. Based on what? Based on the placement of your diode. Now you'll see that with the diode, the positive of the source is connected to the negative of the diode. The negative of the source is connected to the positive of the diode. What does it mean? It simply means that I will have to have a current flowing in that direction. If I've got a current flowing in this direction, how does it look at that component? You will see that with this component, which means there, this component, it is going to be on a reverse bias mode. If it is on a reverse bias mode, which means it is not going to allow the current to flow through. It can only allow the current to flow through if it is on a forward bias mode. Now, if it is on this nature, during the positive cycle, this component is going to, it is not going to react to the forward bias, to the positive cycle of these. It looks at the positive, negative, it says, which means I cannot establish the current, I cannot establish how the current is going to flow throughout this component here because the switch is going to be open. Then the graphical representation of these, it is going to be a graphical representation whereby it is going to allow the entire positive input to go through because it is not coming into that component there, which means when I look at this component, I'm going to look at this component based on my V out will be given by your 100K divided by 100K plus 10K multiplied by 5 volts, which is what? Which is your positive 5 volts, which means this input positively is going to be allowed to go through. This positively is going to be allowed to go through. But now, when the polarity changes, now when I'm looking at it on the negative side, which means here I will have more positive, more negative, there I will have more positive. If I've got more negative here, more positive here, which means now the current is moving in that direction there. If the current is moving in that direction, this is positive, that is positive, which means this component is going to be forced to forward bias. If it is forced for forward bias, which means now I have got this as well. I've got this as 0.7 volts because this voltage and that voltage is bigger, which means it's going to force this component to go into forward bias mode. If it goes onto forward bias mode, which means now my V out, now my V out, it is a V out of what? It is a V out of 0.7 volts. That is when it's going to switch on. Now at 0.7 volts, which means when I measure across these points here, I'm going to measure 0.7. It doesn't matter how much I increase this. It's going to stay at 0.7 volts. But now it's 0.7 volts during what? 0.7 volts during the negative cycle, which means it will be minus 0.7 volts. If it is minus 0.7 volts, then it's going to limit at minus 0.7 volts, then minus 0.7 volts. Then you will see that now the negative cycle, it's no longer oscillating fully, but only a portion of it. If it's no longer oscillating fully, but only a portion of it, which means here it is going to be 0.7 volts, then it clips off, which means the remaining of this entire cycle has been clipped off. Then this becomes your negative clipper circuit. You are clipping off the negative side of the circuit there. Now, this, it's only when you have got this, that as a circuit connection. Now, you will see that with this circuit, you can also bias your input. You can increase your clipping off. You can increase your clipping off. Now, when you increase your clipping off, you will go and check, how do I want to increase this clipping off? When I want to increase this clipping off, I must increase it to a manner whereby I need a constant DC voltage. Now, where's that DC voltage? You will see that here, at those 2 points, that is where you have got your DC voltage. I don't want it to be at 0.7 volts, or I don't want it to be at minus 0.7 volts. I want this voltage to be a little bit higher than 0.7 volts. If I want this voltage to be a little bit higher than 0.7 volts, which means I can go and bias the voltage. When I bias the voltage, I need to bias the voltage connected in series with the limiter. I need to bias the voltage connected in series with the limiter. But the connection, it's very important. The connection, it's very important, which means I can come here and say, my connection, it must be in series. In series how? It must be in series in this manner. The negative of the bias must be connected to the positive of the diode. The negative of the bias must be connected to the positive of the diode. Then the negative, also the positive, must be connected to that one there, which means now I have biased this voltage. Now I have biased that voltage. Now, what does it mean? It simply means that now when I look at this, when I look at this, then I am looking at this in this manner. I am looking at this as, for example, let's say I say this is 3 volts. I say that is 3 volts. Now, compare to this one here. Compare to this one here, which means now I have managed to establish. Now I've managed to establish that I don't want this voltage at 0.3 volts, also 0.7 volts, because that voltage is too little, but I want to increase that voltage. I want to increase that voltage. It simply means that when I measure here, I no longer measure 0.7 volts, but I measure 0.7 volts plus 3 volts. During what? During the negative cycle. During the negative cycle. Now, if I am measuring this during the negative cycle, which means now it becomes minus 3.7, which means now I have got to increase this to minus 3.7, then I clip off the remaining there. Which means from here all the way to there, it is minus 3.7 volts. If this was not there, my V out was going to be 0.7 volts, minus 0.7 volt. But the 0.7 volt, it's a small voltage. So which means I want to increase that voltage or the bias or the clip of voltage. Now, if I want to increase the clip of voltage, then I must go and indicate. How do I want to cut it off? Now, in this manner, which means now it's going to be minus this, minus 3.7 volt. Instead of pushing it to 0.7, then I push it to minus 3.7 volt. But be very careful how this is connected. Now, if it was connected the other way around, what's going to happen? If it was connected the other way around, you will see that if this is connected the other way around, as positive there, as negative there. Positive there, negative there. And that one becomes 3 volts. This is positive, that is negative. What is going to happen here, if you follow the KVL, what is going to happen here, you will see that with this type of connection, instead of clipping this at minus 0.7 volt, you will see that now you are going to eliminate the entire bias signal. You are going to eliminate the entire bias signal. You will limit this entire bias signal up until you even chop off the non-bias signal. You will even chop off the non-bias signal. Now, when you chop off the non-bias signal, then you will see that if this is 0.3 volt, it's going to be, so if this is 3 volt, it's going to be 3 volts minus 0.7 volts, which is 2.3 volts, which means this is going to start at 2.3 volt. Then it oscillates all the way to your maximum, which means you no longer limit not only the negative cycle, but you also limit even a portion of the positive cycle. Then you end up with that small signal there, which means now you don't want your circuit to start at 0. Now it's going to start at a certain voltage there. Now this is when you are biasing. Also, this is when you are limiting your input signal with a bias voltage. Cut.